Now I need to mark the position for the 3 screws that will center the work. I'm going to have one of them at the top and then one down here and one down there, 120 degrees apart. So I thought I would try using the dial indicator to find the center of the top here. And so it looks like it's right about there. I'm just going to make a small scribe mark there. Ordinarily, if I was making this, I would probably use a rotary table oriented in a vertical configuration on the mini mill or even on my larger SX4 mill, because I might need the extra height clearance. But for this project I wanted to use a simpler method that any of you that have a lathe could use. So I'm taking advantage of the positioning of the 3 jaws on the 3-jaw chuck being 120 degrees apart. The top, of course, has to be opposite these 2 holes. I've set up one of the inexpensive import carbide boring tools in the tool holder, but I have it inverted so that the point is on the downward side and pointing in, and I can use that as a scriber to mark my other 2 lines. So we'll bring it over to my initial line here, the one that will be at the top, and just to demonstrate the procedure. Here again, great precision is not a requirement. As long as these are roughly 120 degrees apart, that's all we need to do. I'm going to use the cross feed now to bring that cutting tool in until it touches the side of the work. And then it should begin to etch a line across there. Okay, there's our first line. And now I'm going to rotate it around to the second chuck jaw. And of course I've put some layout die on there. And then we'll just work the carriage forward again, make our second line. And then we'll bring the third jaw around and bring the carriage back out and mark the third line. So that's a quick and easy way to get the job done, and it's more than accurate enough for this project. So I've zeroed my height gauge, and I'm now measuring the thickness of this disc, which is 12.73, and then I'll divide that in half on the calculator. So our midpoint is 6.36 millimeters, and then I'll go ahead and scribe these lines to mark the center point for our screws. Again, if your shop is operating in low budget mode, you can just use a metric rule like this one and one of these inexpensive surface gauges, and then adjust the tip of the pointer till it's about 6.36. You probably have to estimate, 6.4. I have to use my magnifiers to even be able to do that, so it's a lot easier for me to use the digital height gauge. But this will work, and it will be plenty accurate enough for this job. And just for comparison, let me try extending this line. Well, as you can see, the little surface gauge line is almost dead on with the line I scribed with the digital height gauge. To drill the holes, if you have a well-equipped shop with a mini mill, you could just hold the ring in the vise and align the scribe marks with a pointer tool, as I've demonstrated in other videos, and then go ahead and drill it and rotate it 120, and repeat that for all 3 holes. This is not a terribly rigid setup. It's probably okay as it is, but I would probably use a steel or aluminum backing plate on here to give it some additional stiffness, and maybe even clamp the ring to the backing plate with some small C-clamps. But what do you do if you don't have a mini mill? Here's the setup I'm going to use to drill and tap the ring. I set the workpiece in the 4-jaw chuck using basically the same technique that I followed earlier for the plates. The back side of the ring here is actually recessed into the center hole of the chuck a little ways. In order for the hole to be centered, I had to get the vertical alignment just right. So I'm using this temporary spud tool in the chuck as a pointer to line up with the crosshairs. I don't need the quick change tool post for this operation at all. It's going to be strictly drilling and tapping. So I'll remove that just for better access and better visibility. You can see the X mark there where the crosshairs from the layout lines cross over, and I just adjusted the chuck carefully one way or the other until I got the tip of the pointer tool lined up with those crosshairs. So now as I rotate it, it stays pretty much on that center. And of course, if you decide to do an operation like this, you have to be very careful to make sure your workpiece is secure in the chuck jaws. You don't want it to go flying off into the room somewhere. So it's pretty sturdy in there. I'm confident that it will stay where it should be. During the setup, I extended the tailstock ram out pretty far, but that's not really necessary for the drilling operation, so that was mainly just to give me some clearance around the carriage assembly here. Now I'm going to remove the pointer tool, and I'm going to start with a center drill, as I often do, just to make sure I get a good stiff drill in there to start with to get the hole right on center. Then we'll drill it out with an undersized drill, and then ultimately we're going to tap it M6x1 for these bolts. Bolts came from this set from Harbor Freight. It's item number 67624, and it has a pretty good assortment of 460 pieces. They're M5s, M6, M8s, so they're mostly what I would call larger sizes, at least relative to the mini lathe. But it's a good assortment, and I find lots of uses for it around the shop, and I think they're pretty good quality considering the very low price. I've put the actual tap drill in the chuck. Like most tap drills that come in a set with the taps, it's shorter than a standard jobber drill, which is an advantage in this case. But this whole setup still takes up quite a lot of room along the bed here. So let's see how that plays out depending on the size of lathe you have. This lathe is a 7x16, so that's the 7x16 end of the bed there. So a 7x14 would end here. A 7x12 would end here, and as you know if you've been following my videos, there is no actual 7x10. The Harbor Freight 7x10 is in fact 7x8, so the bed would end there. So what you can see from this is if you have a Harbor Freight quote 7x10 unquote, you're not going to have enough room to do this job, but it looks like it could be done without a problem on a 7x12 or a 7x14 or of course a 7x16. In a setup like this, I don't want this ring spinning around at high RPMs, and there's no real need for that. So don't be overly concerned about using the optimal RPM, based on the drill bit size or any of that. I'll just pick a slow speed, say 400 or 500 RPM, and that should be fast enough to get the job done and leave a clean hole while keeping the whole operation a lot safer than if we were running at higher speed. You may have noticed that I didn't use any protective material under the chuck jaws to keep it from scratching the work, and there's basically two reasons for that. One is in this configuration, the sides of the jaws that are touching the work are actually smooth, so there's less risk of the jaws in this position creating indentations on the surface of the work. But number two, this poor workpiece has been beaten to death through this whole process, probably a lot more than it would have been if I was just working on it and not doing the video, because I've tried many trial configurations just to accommodate, things that you may or may not have in your shop. Last of all, if it gets beaten up a little too much, I'm planning to do a little surface finishing on it when I'm all done, so it should come out with a nice clean finish in the end. So we'll just give the workpiece a spin, make sure it's secure, it's not going to hit anything, and then we'll turn the speed control down so it doesn't start up faster than we want. And I'll gradually increase the speed up to about 500. So that's about 500. I'm at 600 now. That looks good. Fast enough to get the job done, slow enough to be safe. Going to put a little Tap Magic aluminum on the drill bit. Make sure my tailstock's locked down. In fact, I'm going to go up to 700, 800. Yeah, 800's better. It's cutting better. So I got a nice clean starter hole there. Get these chips out of the way. I'd probably be fine just going in with this tap drill directly, but I'm going to be conservative and use a starter drill bit first. Now here again, this is a longer drill bit than the one for the tap drill. If you have a short machine, you may not be able to do this step. By drilling a smaller hole in advance, the tap drill has less work to do and is more likely to cut a properly sized tap hole. I'll use some Tap Magic aluminum on there. I left the speed control set to about 800, so we'll use that same speed. This is a fairly deep hole, so I'm going to withdraw the drill bit and put some more tap magic on here, clear the chips out of the way. I just unlocked the tailstock and drew it back. That's quicker and easier than using the hand wheel. Alright, and we're through. Now I'll drill through with our tap drill, which is a 5mm. Now I've put the tap into the drill chuck, and I'm going to actually tap under power. The locking handle on the tailstock pulled back to the point just before it starts to lock up, because I don't want the tailstock to tilt, but I want it to be free to move forward and backward along the ways. Once I'm going to start out with a low spindle speed, push the tailstock until the tap starts to bite into the work, and then let the tap pull the tailstock into the work. Put plenty of tap magic on there. This can be done at very low RPM. I'm running into, according to the tack, I'm down about 240, which is plenty fast. I could even go lower than that. I think I'll go a little lower. Okay, I'm about 200 now, according to the tack. The tap jammed up in there, and the tap itself was starting to spin in the chuck. So, number one, I'm going to tighten the chuck up a little bit. Typically can't cut the thread all in one pass. Usually have to reverse the lathe and back it out and make multiple passes, and that's going to be the case here. So I'm going to put the lathe into reverse and start it up, and it should push the tap back out. There we go. I'm going to put it back and forward, but I'm going to keep my hand on the forward reverse switch, and I'm going to switch back and forth between forward and reverse. So when it starts to cut in, then I'll reverse it. Yeah, it's still a pretty big bite for this. Just noticed one other thing that I should have been watching out for, and that is that the tailstock was butting up against the carriage. I should have made sure that the carriage was farther forward so that the tailstock wouldn't run into it. That may have been contributing to the problems. Well, that wasn't a very elegant demonstration, but I think the threads will work. Let me just double check and see. Kind of tight. I need to run that tap through there once more, I think. I'm going to blow a little compressed air in there. While I still have the ring set up in here, I'm going to just turn the work by hand and chamfer the edges of that tapped hole, and I'm going to do it on the inside as well. So I can reach in here and just twist this around by hand. That should be good enough. Around 120 degrees to bring the next position out to the center line of the lathe. So I'm going to loosen just jaws 1 and 2 just a little bit, and then I'll bring it into approximate position and snug these up. Since I haven't changed jaws 3 and 4, theoretically just tightening these two jaws should bring it back into the correct vertical alignment, but we'll see. I need to tinker with the adjustment just a little bit until I get the X lined up there under the point of the tool. Looks pretty good. Yeah, that's close enough, so we'll go ahead and drill and tap that one now. Okay, I'm set up for tapping. I've made sure the carriage is far forward so that the tailstock doesn't run into it. I've tightened the tap up in the chuck. Hopefully it will cut without slipping in the chuck this time, but we'll see. I'm just reversing the motor back and forth to clear the chips out. Using about 40 pounds of pressure, and I'm not even depressing I'm not even pressing the button all the way down, so it's fairly low pressure. Doesn't take much. Feels pretty good. If you're not experienced with tapping, a better way to do this is not use power at all. You can just bring the tap up and using hand pressure get it started in the hole, and then turn the spindle by hand or with the ring even. Probably better to use the chuck so you don't knock the ring out of alignment. Because it takes quite a lot of torque in some cases to tap a hole, you may have to use the chuck wrench to be able to turn it to cut the threads, and then remember to back off every once in a while to break the chips free. That's especially important with aluminum. It's also very important with aluminum that you use some sort of cutting fluid. Tap Magic aluminum, as you know, is the one I tend to use, but there are other good brands out there, and you might even try WD-40. I think some people have had good success with that. This project has required me to change back and forth between the 3-jaw and the 4-jaw chuck a lot more frequently than I usually do. On this lathe, which is the Little Machine Shop Model 5100, it has a 4-inch spindle and takes a 4-inch diameter chuck as standard. These chucks are bigger and heavier than the 3-inch chucks that are used on most of the mini lathes, so trying to get the first nut started on here is a little risky. The heavy chuck can easily slip out of your hand and fall on the ways, so of course you want to have a protective board underneath here. Just for comparison, this is the 4-inch 4-jaw chuck lined up next to a 4-inch 3-jaw chuck that would be used on most mini lathes, and you can see that there's quite a difference in size, and this one probably has almost 3 times the mass of the smaller one. So the little one you can easily grip in your hand while you're tightening the screw, but that's not quite so easy with this bigger one. So I came up with this little aid here, and I just slipped the chuck on, and then I made this slide-on adapter here. This is just a piece of aluminum that's been bent, and as you can see, I just quickly slipped it there, and it holds the chuck in place while I get that first nut tightened up. Once you get one nut on, then it's safe to remove it. This gadget took me probably 5 minutes or no more than 10 minutes to make. I just found a piece of scrap aluminum and I bent it using a vise and a dead blow hammer. I think I actually bent it around some 1, 2, 3 blocks to get a sharper bend, and then I just finished off the corners on the disc sander, and there you go.